Newton's third law we had done. Vidal, Zale start. And question numbers, what we had done last? Only the applicative part, applications, right? Okay. So, what was Newton's first law of motion? Every action every object at rest or in the state of motion always will remain in that state until an external force applies on it. What was Newton's second law of motion? The momentum of any object, change in momentum of any object is said to be directly proportional to the force. From that, we got another formula for force. What was that? F is equal to mass into acceleration. What was Newton's third law of motion? Every action has equal and opposite reaction. F force A suppose B आचेर force apply करता जाल्यार B सदांच A आचेर equal force apply करते. Then we had seen the applicative part of it. As of now, let us just keep question number 5 on hold. Let us go to question number 6. Read question number 6. You all got the paper? Arjun now? 12, they have got already all the papers. Read question number 6. Two masses 8 kg and 12 kg are connected across the ends of pulley. Calculate tension and acceleration of the system. What is pulley? Pulley म्हणल्यार कितें? Well, you all have seen. By पहिला, बांचेर उदक काडटा ते पहिला. That is called as what? Pulley. So rope घालतात. On one end you try to pull it. On other end there's a bucket connected. So तसोच pulley हांगा सांगला. There is one pulley over here. And there's a rope that is put around that pulley. Rope that is put around that pulley. आता single rope असतलो काय दोन rope असतले? Single rope, no? Yes or no? So what is connected across the two ends of the rope? Two masses. एक असा आमचो 8 kg. Don't write anything, just pay attention. And second one is 12 kg. Yes? What you have to find out? You have to find out tension. And second, acceleration. Very, very important concept. New MCQ based. Some formula, some laws of motion has maximum marks for JEE and NEET. तिथून सगळे questions असले types असतात. Okay. So Goa Bodak, I don't know whether all the colleges will do this type of problems. But I may एक करूया so that you get a brief idea. Okay. Now come back to the real life thing. Suppose this pulley was there. एक pulley आशिलो. तेजा surrounding suppose आम्ही एक rope घातला. One end is connected with 8 kg and other end is connected with 12 kg. What do you think will happen? Or suppose real life unpresent असं. What do you think will happen? 12 kg किती जातलो? सकल देवतलो. 8 kg किती जातलो? वयर येतलो. So 12 kg will accelerate downward, whereas 8 kg will accelerate upward. Both acceleration will be same or different? Why different? One is coming down, कितल्या त्यांना तो दुसरो वयर वयता. So both will go with the same acceleration, no? So if one is coming down, other one will go on. Is that clear? Second thing, I want you all to tell which are the different forces acting on these two objects. Start with this one. Mass म्हणतात आम्ही तेका. Weight of it acts always vertically downward. Can I write it as 12G? M is 12, no? Other force? It is tied. It is tied. tension force towards where it is set. mg 8g zalo. Should I write it as T1 and T2? Yes? No. Yeah, Dora. If the rope is same, tension will always be same. If the ropes are different, suppose something like this is there. आता दोन ऑब्जेक्ट्स ट्राय केले, हांगा एक रोप यूज केला, मधी आणि एक रोप यूज केला. So this is a different rope than this one. Okay. So hanga you will take say T1, here you will take say T. But here it is a single rope throughout. Don't different parts asa no. So when rope is same, tension will remain same. Is that clear? Okay. Now how to start solving these numericals? You have to write force equation for these two objects. What is your force equation? F is equal to mass into acceleration. Now try to think about this. What is this force? Force is the force that is acting on the body. Ata suppose I have one body like this and I'm pulling it with forceps. I am not sure any other forces over here. Which is the only force acting on it? F is equal to say 12 Newton. Someone is pulling it only in this direction. So what you will write here? F is equal to mass into acceleration, and F will be 12 equal to whatever 8 into acceleration. Yes, in this case. If someone is pulling it this side with say 8 Newton. Now what you will write Fx? Jenna एक force ashilo, आम्ही direct 12 बरेलो. Now how many forces are acting on this? 2 forces. So hanga F yochina, but hanga what will come? Net force. Net force kenna eta? When there are more than one forces acting on a particular object. Okay. So how many forces are acting here? 2. How are they acting? Opposite. Opposite asla kiti korap asta? Subtract. So what it will be? 12 minus 8 is equal to mass into acceleration. Very important. Huh? Suppose I have an object like this where 2 people are pulling it with 12 Newton and F2 is equal to 8 Newton. What will be my F net here? How many forces? First of all, fakta F etlo ga F net etlo. F net. More than one force aslo ke F net gala. Now what it will be? How many forces are there? 2. How are they moving? Same direction. So what you will do? 12 plus 8 is equal to mass into acceleration. Simple. Okay. So same way you have to write the equation for force for these two objects. Write down for the first object 8 kg. Sanga, how many forces are there? On 8 kg, how many forces are there? एक असा का दोन असा? There are 2 forces. Which are those 2 forces? Pay attention first. My bariyat. Which are those 2 forces? Mg acting downward and tension acting upward. 2 in opposite direction. Yes. So what it should be? Separate. So is it T minus Mg or Mg minus T? Anything? Is it T minus Mg or Mg minus T? See here. If someone is pulling me this side with 20 Newton, which side will I move? Which side will I accelerate? That side. If someone is pulling me in this direction with 20 Newton and someone is pulling me in this direction with 10 Newton, which side will I accelerate? 20 Newton, 10 Newton. So acceleration which direction and this side. ज्या डायरेक्शनान चड फोर्स असतलो त्या डायरेक्शनान सदांच कितें जावपाक जाय acceleration जावपाक जाय. So my 20 is greater than 10. कळ्ळें म्हाका? This force is greater. So ज्या डायरेक्शनान acceleration जाता that force will always be greater. Now look at this. I have tension going this side, mg going downward. Who is greater? Look here and how you know? Acceleration is taking place upward. जो फोर्स चड असतलो त्या फोर्सान ऑब्जेक्ट वयर वयता. So what it will be? F net will be what over here? Tell me, F net will be what over here? T minus H is equal to mass is how much? Into G you can take 10 meter per second square. G is acceleration due to gravity. mg, no? Now tell me for the second one. What you will write? How many forces are there? Two. Minus sign your pug there. But who is greater? What minus what? 12g minus t is equal to force is equal to mass into acceleration. Now take both the equations. I'll rewrite it. 8g is equal to 8a. Can I write this as 80? Yes. G is how much? 10, no? So 8 into 10. And minus t I'll write here. Plus 120 is equal to 12a. Now what you have to find out? Tension and acceleration. So पहिले हांगच्यान कोण मेळटलो आमकां? Your elimination method. T and minus T will get cancelled out. So what will be left here? Plus how much? 40 is equal to 20A. So from this A will be how much? 40 upon 20, 2 meter per second. Once you get acceleration, can you put it in one of the equation and get T? How much it will be? T minus 8G or 80 is equal to 8 into 2. So this will be minus 80 is equal to 2 at the. So T will be 16 plus 80. So kitlo zalo? 96. Kon taught? Who is this? Tension is what? What force? So what it will be? Newton? No, force is Newton. So this is the way to solve this type of problems. Once you are firm with this concept, no, Fnet, you can solve any type of problems. फक्त भुरगी कन्फ्यूज खंय जातात एफ बरोवपाच्या टायमार they don't know which F to take. They take only one F. They take only this F. They don't. Some people don't know what is T. They take it as seconds. Time म्हणा consider करता हे केन्ना जाता when you don't listen. So once you know एक ऑब्जेक्टाचेर if there is only a single force then F will be that force. एक ऑब्जेक्टाचेर if there are two forces acting you have to check what. How are they acting? If they are acting opposite direction, your F will be this minus this, which side the acceleration is taking place. If there is an object on which two forces acting in the same direction, what will be F next? You have to add it. As simple as that. Note it down. Done? Okay, see here. What will happen to the object? What will happen? It will be at get press. Because both sides, the force that is applied on the object is equal. So what will be total force that is acting on this object? Zero. So it will be at rest, or acceleration will be equal to zero. Okay, so you have a formula, F is equal to F net is equal to mass into acceleration. In this case, your F net is equal to what? Zero. So this side it will be mass into acceleration. LHS have to be equal to RHS. Okay. Can mass be above be equal to zero? हे आम्ही logically understand केले आता. When any object touches, suppose F net zero झालो, mass can ever be equal to zero. Mass can never be equal to zero. So A संजन zero झाला, हे संजन कोण zero जाऊ then that's it. Acceleration will be equal to zero. So always remember, if there is no force or a net force on an object is zero, that means acceleration of that object will always be zero. Okay. What you can say? How much force is acting on this object? How much force is acting on this object? I have not mentioned anything about the force. हमें फक्त सांगला एक ऑब्जेक्ट असा तो constant velocity move जातो. How much is the force acting on this object? Everyone. It will be, how you know that it is zero? Constant velocity means acceleration is zero. You know F net will be equal to mass into acceleration. If acceleration is zero, then F net have to be equal to, because Hanchan zero, zero into mass is zero. So F net is what? Zero. That means total force acting on that object is zero. Now you will create a question to play. This is in motion, huh? This is in motion. Any question is coming in your mind? No? Here also acceleration is zero, so force is zero. Here also acceleration is zero, force is zero. But there what is happening to the object? It is at rest. Here is it at rest? So object, even when the forces are equal in opposite direction, not necessary that the object will always be at rest. It might be moving, but moving with what? It is moving with, say, some constant velocity. Take ball, a constant velocity in वयता, कोण तेका धुकळना, कोण तेका ओडना, it is still moving. Net force on it is what? Horizontal force. You will say mg astalo. I'm not talking about vertical. Vertical and horizontal different जाता. Here we are talking about which forces? Horizontal force. हांगा mg बीमार करूना पळय. Vertical forces we are not talking about. We are talking about in which direction it is moving. Acceleration कोणत्या direction जाता? Horizontal. I'm not talking about vertical forces over. Okay, so if there is a constant velocity or if the object is rest, then we can say F net is equal to, again, a very important question. Now you will ask like what questions you will get on this. You will get applicative questions on it. So a concept yaad urpadu. No one will tell you to write this. This will never come to write as in like F equal to mass into acceleration, F net zero ना तशी होती ना they did applicative questions like object is moving with constant velocity. How much is the force acting on it? What will be the answer? So that is the way you have to answer. Note it down. Next slide. Derivation of Newton's third law from second law. I don't know how many derivations they are going to do for you all. So जी तुमका कॉलेजीन करता ती तुम्ही शिकपाची मग exam एका. These are small ones, so I'm doing it anyways, which are there on your text. Derivation of Newton's third law from second. Write down. Consider two bodies A and B colliding with each other. Okay, just pay attention here. A and B are colliding with each other. That's certain. So A will exert a force on B. Push करतो लो. So force on B due to. Similarly, B also will apply an equal force on A due to. According to Newton's second law, what it says? According to Newton's second law. याद करत. What was second law? Force is equal to dP upon dt. Force is equal to change in momentum per unit time. किती याद दरपाक सांगलेले for this? Which concept? Bat and a ball. When you hit the bat, when you apply a force on the ball, the momentum of the ball changes. Okay. So force, first we'll write this one and then this one. Force on A due to B. Force on A due to B. You have to write the same formula. Instead of force, I have written force on A due to B. Now, whose momentum is going to change? Force on A due to B, meaning who is applying a force on whom? B is applying a force on A. Force on A due to B. B is applying a force on A. So whose momentum will change? Momentum of A will, equation 1. Second, force on B due to A. Whose momentum will change? A is applying a force on B. Whose momentum will change? Momentum of B will, add equation 1 and 2. Add equation 1 and 2. LHS add करा, RHS add करा. सांगात किती असले? FAB will be plus FBA will be equal to DPA dt plus DPB dt. Yes. Now, how are both the forces acting? Opposite. So, what will be FAB plus FPA? Will it not be 0? One is positive, one is negative, no? Both are equal in value. So, this will be equal to, can I take one term on the other side? Minus dpp upon dt. Now from equation 1 and 2, what is dpa upon dt is equal to FAB. Minus what is dpp upon dt? FP. So have you proved Newton's third law from second law? I know this is a bit boring, but unka derivations येतात, so I have to do, and these are like small derivations. Okay, so note it down. Done? झाले? Next, write down law of conservation of linear momentum. Law of conservation of linear momentum. Very, very important topic. Law of conservation of linear momentum. What do you understand by this statement? Law of conservation of linear momentum. Conservation of linear momentum म्हणलं गेलं. Conservation, conserved. Word? Conserved means what? Safe or not changed. So conservation of linear momentum means suppose एक isolated system असा. Isolated system means what? One isolated system is there. Isolated system. What is isolated system? Isolate केलं म्हणल्यार किती म्हणा? There is no external force acting on these objects. Inside there might be objects. एक object असा, 2, 3, 4, 5, so objects असतात. They are moving, they are having mass and they are moving. Velocities असतात त्यांचे. So each one is having a momentum. Mass into velocity gives you momentum. Internally, maybe their momentums are changing. Changing or not changing? Mass into velocity. Okay. But if it is an isolated system, that means if there is no net force acting on it, or if the net force is equal to 0, भायल्यानच्यान suppose कोणूच तेजेर force apply करना, जाल्यार internal जो momentum असा तो सदांच कितें उरतलो throughout total momentum of all the objects together. कितें जातलो? It will remain same. It will remain conserved. Conserved or same. आणि एक example असा एक derivation तुम्ही बरयतली. I will just explain that. If two vehicles are moving and if they dash, collision has happened between what? Only the two vehicles. Is there anyone else coming and dashing with them? No. So no external force is getting applied on it. So collision is taking place only between the two objects or two vehicles. So the two vehicles किती झाली? Isolated झाली. They were not isolated when others were coming and exerting a force on it. Okay. So if two vehicles were moving and if they collide, if they dash with each other, there is no other party involved there. And then they will start at the collision. Two vehicles come, they collide. Suppose imagine one vehicle was moving with say 40 km per hour. Another vehicle is coming with 100 km per hour. What will happen? Dash satli. 40 and 100. Definitely 101 will come and dash. Collision zale. Next kid zatle. Okay, take lesser otherwise. Back one is coming with say 70 km per hour. Came and dashed. Major accident also na. Kizatlo, dash satlo fuck. Mukar kizatle. They will stop and stay there. What will happen next? They will move. They will move further. Will the first one go with 40 and second one will still go with 70? Their velocities are going to change. Yes or no? They may be kami third, whatever different velocities that leave. So individually their momentum is changing or not? Changing. This one was initially 40. So maybe the velocity changed. So momentum has changed. Similarly, the other one. But what I'm trying to say is conservation means what? The collision has taken place between whom? Only two vehicles. Was there anyone else come into picture? कोणे हाडून त्यांका दुखळे? ना. त्यांच्या दोघांच्या मधी collision झालो. So they are what type of system? Isolated system. So what I'm trying to say is combining the momentum initial before collision momentum of the first and the second car will always be equal to The momentum after collision of combination of first and the second car. After collision सुद्धा त्यांचा individual momentum change जातलो, but throughout momentum will always remain same. We are going to prove it. Okay, that is called as, and when that will happen? Condition is what? When it will happen? It has to be an isolated system. What do you mean by isolated? External force supply जावपा येना. झगडी तुमच्याच दोघांच्या मध्ये जावपाक जाय. No, other one should not come and beat you. Then it is an external force. It should be only between two. So your momentum is going to change, but combined momentum will always remain conserved before and after. Okay. So let us take the first one. Proof of law of conservation of linear momentum from Newton's second law. Consider an isolated system. Consider an isolated system of n particles. N number of particles, you write. N number of particles. Small n, n number of particles having mass m1, m2, put dot mn. Mn. M1, M2, that 1, 2, n, you have to write it as a subscript. And velocities V1, V2, put dot Vn respectively. Now just pay attention here. What do you have? Isolated system. तिथून किती असा? N number of particles असा. प्रत्येक party. Suppose this is the first particle. ह्याचा mass कितलो दिला? M1. Velocity is how much? V1. It is velocity is given, means it is moving. Second one M2, V2, and so on. And last one Mn, Vn. Okay. Each particle will have what? A single momentum. What will be that called as? P1. So what will be the momentum of the first one? Don't write anything. Momentum of the first one, M1, V1. What will be the momentum of the second one? M2, V2. What will be the nth one? Mn, Vn. Saglango concept follow. What simple concept. Huh? Now what will be the total momentum of the entire isolated system? Total momentum of the entire isolated system. What you will do? You are going to add up all the momentums. That will give you the total momentum. So what it will be? P1 plus P2 till. Correct? Now, according to Newton's second law. What was second law? F is equal to dp upon dt. F is equal to dp upon dt. F net net or F, whatever. Now this is for isolated system. For isolated system. किती सांगलेलं आता? What is not present? For isolated system, F is equal to 0. Isolated system म्हणला, there is no force acting on that system. So F कितलो जातलो? F will be equal to 0. So can I put it here? F will be equal to 0. So can I put it here? F0 gatle. So what I'm left with? For an isolated system, force is equal to 0. So that 0 I substituted here on LHS. RHS asto barelo. What do you mean by this statement or this equation? If you put it in a statement, how will you put it? D by dt millar kide? Change. Very good. Change in a particular physical quantity. What do you mean by this statement total? Change in momentum. Change in momentum per unit time is equal to 0 means what? Change. Put it in a statement and tell me. Change in momentum per unit time is equal to 0. Meaning what is happening to momentum? What is happening to momentum? Changing or not changing? Change in momentum is equal to 0. म्हणल्यार momentum किती झाले? Change जाता का change जायना? It is not changing. This means that momentum is not changing. If momentum is not changing, that means momentum किती झालो? Constant. Change in momentum is equal to 0. Anything किती? D by dt. Whatever quantity it is equal to 0 means that quantity is constant. Have we proved it? What we were saying? When for an isolated system, when there is no external force acting, what is happening to momentum? It will always remain conserved or constant. Is it constant from Newton's second law when F is 0? So this is one thing. Then we'll take the second one. Done? Next one, proof of just one more. I parat question settle. Proof of law of conservation of linear momentum. Proof of law of conservation of linear momentum. From Newton's third law. First one, what we did was second law. This is from third law. Write down, consider two bodies. Consider two bodies, A and B, of masses m1 and m2, moving in same direction with velocities u1 and u2, where u1 is greater than u2. u1 is greater than u2. They collide for time delta t. Write it like this. For time delta t. What do you mean by delta t? Small fraction of time. For time delta t. After collision, the velocities will be, after collision, their velocities are, don't write will be, are v1 and v2. Okay, just pay attention here. There were two bodies, A and B. This was before collision. Sangat, Vachat and Sangat. With what velocities they were moving? A was moving with u1, B was moving with u2, such that u1 is greater than u2. When this one was moving with 80 km per hour, this one was moving with say some 50 km per hour. So hoyatlan gitzatlo, it will dash this one. So hanga collision zatlo. They will collide. When they collide, for how much time are they colliding? A fraction of second delta t. So what will happen at this place when they are colliding? A will exert a force on B. As a result, B also will exert a force on A. So FBA, FA, correct? And after dashing, what will happen? Will this be there? Stop? They will start moving in some different velocities. So after collision, A and B starts moving with velocities v1 and not necessary they will move only in this direction. Direction doesn't matter for us right now. What matters is their velocities are changed. Okay. So according to Newton's third law, tell me. Newton's third law. What is Newton's third law? FAB is equal to minus FP. आमका आता FAB and FPA find out करपाक जाय so that we can substitute it in this. So for this, we are going to find out the equation for impulse. What was impulse formula? Doन formula आशिले impulse चे. Impulse formula was what? It's only gone. F upon F into time. And what is the other formula for it? MB minus final momentum minus initial momentum. So let us try to find out what is the impulse that is exerted on A. Impulse on A. Impulse A when B will exert a force on A. Okay. So what will be impulse on A? Formula is what? Force into time. So what will be that force? Force on A due to B into delta T will be equal to what? Who's MB? Whom you are talking about? A. V means what? Final velocity. U is what? So what you are going to put? What will be the mass into final velocity of A minus mass into initial velocity of A. So what it will be? Mass into M1 into ends of mass M1 and M2 we have to take. So M1 into V1 minus M1 into U. We are talking only about A right now. B has exerted a force on A in time delta T. So the momentum of A has changed from V1 to V2. Sorry, U1 to V1. I'm repeating again. We are finding out impulse on A. त्यांना त्यांचा accident झालो, त्यांना A याचेर कितलो impact आयलो. Okay, how much was the impact on A? It is force on A due to B in time delta T, which is again equal to change in momentum of whom? A. So change in momentum म्हणला तिची final velocity कितली? M1 V1. Initial velocity is how much? M1 U1. Similarly, can you tell me what will be the impulse on B? FBA into delta T is equal to what was the final momentum? M2 V2 minus M2 U2. See, it is simple. आता किती झाला तुम्ही गेलात तो झोन हांच्यान क्रॉस करून हांगा पावलो आता. सो ते आता ते इवन 1+1 सुद्धा सांगल्या तुम्ही आन्सर दिवची ना म्हाका. तुम्ही 3 सांगतली ना अशें पळयत रावतले म्हाका व्हॉट इज 1+1 काय कळना. You have reached in that zone now because we are doing only derivative, but I cannot leave this in between. थोडे concepts आसा ते करपाकूच जाय because they come for the exam. Now I'm not sure which derivation will be done in which college. And it is not that these are huge derivations. इतली मुखार फ्लुइड्स चॅप्टर आसा तितून सगळ्यात एक्स्ट्रीम लेवलाचे डेरिवेशन्स आसात. सो दोज यू आर गोइंग टू डू. मागीर दिस एग्जाम ओनली यू हॅव दोज कोलिजन डेरिवेशन. द फूल बोर्ड बी भरता पुसून परत आनी बरोवचे पडटा. मागीर तेन्ना आनी विदाल तर सामको बेड बी हाडून घालची पडटली न्हिदपाक. He has slept half asleep, but I'm not saying anything to those who are sleeping. Nidat जाय ते करा if you all can manage later on, well and good. So this is clear. We are talking about impulse on A. So impulse on A कसो मेळटलो? What is the formula? Force into time. So who has applied a force on A? Force on A due to B. In how much time? Delta T. Because of that force, what happened? Its momentum of A has changed. Momentum is what? Mass into velocity. Mass तसोच उरतलो M1. Velocity किती जातली? Change जातली. So final is V1, initial is U1. As simple as that. So it will be for second one. Now from this, what I had told you all, we want FAB and FBA so that we can substitute. So are we going to get it from here? Yes or no? Or equation gayat? Or equation gayat? What will be FAB? What will be FAB? There is delta T with it. So where I have to take this delta T? On the other side. So what it will be? M1 V1, M1 U1 upon delta T. Equation 2. What will be FBA? M2 V2 minus M2 U2 upon delta T. Equation 3. Now what you will do? Substitute 2 and 3 in 1. Sangat maga, FAB is what? M1 V1 minus M1 U1 upon delta T is equal to minus, because there's a minus sign here, it will be M2 V2 minus M2 U2 upon delta T. Now what will get cancelled out? Delta T. Okay. Before we come to the answer, आमकां कितें करपाक सोदताले आमी हांगा? We wanted to conserve linear momentum, combined linear momentum. So can you tell me, before collision, what was the combined linear momentum of both together? Combined means what? Addition of two. So what was the linear momentum? M1 U1 of the first one plus M2 U2. This is the momentum of that isolated system before collision. After collision, what will be the combined momentum? M1 V1 plus M2 V2. आता as per logic that we are studying, आमका किती prove जावपाक जाय? That momentum has to be equal to this moment. Then only we can say your entire momentum is conserved when no external force is acting on it. Is there any external force? No. दोघूच जण apply करता एकमेकाचे force. So tell me now. Let us solve this. M1 V1 minus M1 U1 minus sign भितर multiply केला किती येतले? Minus M2 V2 plus M2 U. Yes. Now you know we need plus signs. So let us try to change it. Negative असतो तेवटेन वेळेला plus जातलो तो negative असतो हे संजय नाडलं plus जातलो. So M1 V1 plus M2 V2 M2 U2 plus M1. Have we proved it? Initial was how much? M1 U1 plus M2 U2. That is equal to final M1 V1 plus M2 V2. फक्त values interchanged, but addition is. Okay, hence true. This comes for the exam. Simple derivations. निदाल खबरच म्हणजे सब्जेक्ट खंयचो तो? हां, फिजिक्स. ना केमिस्ट्री बुकाचेर बरोवशी. Let us take some applications of conservation of linear momentum. Next page. Recoil of gun will come after this. First, we'll take the normal theory part. While firing a bullet, the gun should be held tight to the shoulder. जेन्ना अशें धरून bullet fire करतात, it is always said you have to hold that gun tight to the shoulder. If you hold it loose, what do you think will happen? With what velocity the see bullet and gun both are what type of system it is? Is it not isolated system? Yes or no? Now you say I press the trigger, but bullet is coming out. You are just trying to get it out. But bullet is actually coming out because of what? Gun is applying a force on it, no? There's no other. You are not pulling the bullet out. Bullet is coming out because gun is applying a force on it. So as a result, the bullet will also apply a force on the gun. So bullet, suppose ज्या velocity in भायर सरता, जाल्यार because of the force that is applied by the gun on the bullet, bullet goes out with so and so velocity. What happens to the gun? Gun remains there. Bullet is also applying an equal and opposite force on the gun. So gun also will come backward with the same force. It won't be, force will be same. But why the velocity doesn't remain same? Why the velocity doesn't remain same? You feel. Atla the concept. I'll do that, recoiling of a gun. Then you will understand. Because of the mass. Bullet and gun compare karat. Whose mass is more? त्याचो मास चड असता त्याची velocity सदांच कमी आसा. We'll take that first. Otherwise, recoiling of gun. Just read it. Recoiling of gun. Recoil means what? The gun coming back. Recoiling of gun. M1, M2 dila. Tell me what is M1, M2. What is V1, V2? M1 is what? Mass of bullet. What is M2? Mass of gun. What is V1? Velocity of bullet. What is V2? Velocity of gun. Initially, bullet is inside the gun, both are at rest. So, initial velocity U1 and U2, दोन्ही कितने 0 that. Okay. Now it is an isolated system. Yes. Before firing the gun and after firing the gun, what should remain conserved? Gun and bullet are what? Both are together. When the bullet is coming out, why is it coming out? Because gun has applied a force on the bullet. As a result, bullet will also apply force on the gun. That is why you know gun is coming backward, bullet is going forward. Is there anyone else exerting a force on them? So to कसलो system zalo. If it is an isolated system, then what will happen to linear momentum? Before firing and after firing, what should happen? That is why that you had to listen from the beginning. So what should happen to the linear momentum before collision? Also, whatever it is applied to anything. What should happen before and after firing? If there is no external forces acting, it should remain same. So what is the gun and bullet? What will be the initial momentum of these two? It will be M1 U1 plus M2 U2. For initial zalo. Before firing, should be equal to after firing. After firing, kitlo zatlo? M1 V1 plus M2 width. Initial velocity सगळ्यांची 0 असा because they were at rest. So ही side 0 झाली. So what is left? M1 V1 plus M2 V2. बुलेटाची मास कितली आशिल्ली? M1 and V1. We know that bullet will definitely go with certain velocity. What you want to find out? With what velocity the gun is coming back. So you want to find out what? V2. So I'll find out V2 how? M2 V2. This I'm taking on the other side. M1 V1. So what will be your V2? M1 V1 upon M2. So how suppose आम्ही constant consider केलो as of now. Then how is V2 related to M2? Inversely proportional. What it tells you? Bullet is going forward, gun is coming backward. How is the velocity related to mass of that object? Inversely proportional. Lesser the mass, more will be the velocity. So see, when the bullet is fired, gun is exerting a force on bullet. Same force is applied by the bullet on the gun. Then both should go with the same velocities, no? But they are not going. कित्याक वचना? Bullet बारीक, so तेजे force चड exert जाता. I mean तेजी velocity चड जाता. Not force चड, but velocity चड जाता. Whereas gun is heavy, mass is more, so तेजी velocity कमी जाता. So the question asked over here is, while firing a bullet, the gun should be held tightly to the shoulder. What you will answer? Why you have to hold it tightly? If you don't hold it tightly, what will happen? It will come backward and your shoulder will get injured. Because with what force the bullet is coming out, with the same force the gun comes. So you have to hold it tight so that it increase when you hold it tight. Simply things will not work. Huh? When you're holding it tight over here. कित्याक injury जायना. Velocity कित्याक देवता. When you hold it like this, imagine, when you hold it like this, हाक येवन बसतले, injury जातली. Correct. Because you will say velocity सामकी कमी जावची ना. Yes, no. Bullet, imagine with what velocity is going. So तेजी मातशी तरी velocity आसपाक जाय हांगा. When you hold it tight like this, why do you think the velocity drops completely? Because it stops. Anyone? हांगा आसतना body mass and gun mass was separate. So it was coming back. When you hold it here, this one became a part of your body now. Connect zalo nahi. So overall mass kit zalo. Increase zalo. So overall velocity kit zatli. Decrease. Is that clear? So answers are given over there. Flight of rockets and jet planes. Read it. This is same as what I had explained last time. Okay. And the last one ek read kara. An astronaut in an open space who want to return to the spaceship throws some object in a direction opposite to the direction of motion of the spaceship. By doing so, he gains momentum equal and opposite to that of the thrown object. And so he moves towards the spaceship. Suppose he's coming out, he cannot walk, no? There, no gravity. So suppose ताका spaceship आणि येवपाक जाय जाल्यार ताणे कितें करप आसता? Throw object against the spaceship हांगा आसा जाल्यार you have to throw this side. So what will happen? Equal force is applied on him. So he goes backward towards the spaceship. Okay. We'll stop here. So next class, I'm doing friction. Very, very important topic again. So मिठा खबर आसा मातशें करपाक जाय म्हळ्यार हेल्प